So if we have this graph right here, where we have functions y equals 2x and y equals 1/2 x, these are the inverse functions of each other. And they are reflected over each other over the y equals x line. And like if you swap the x and y values, you get the other function. So let's try for this one. Y equals 2x, replace y with x and x with y. So we get x equals 2y and y equals 1/2 x. And we get this function here, they're the same. And when we want to take the derivative of inverse functions, we can do it in two ways. First of all, we can either rewrite the function as its inverse, like we did right here, or we can just take the derivative of the original function and take the reciprocal of that. And this makes sense because as we notice right here, the derivative of 2x is just 2, and the derivative of the inverse is 1 over 2, because the slopes are reflected over the y equals x-axis, which means they are reciprocals of each other. However, you must remember that for inverse functions to exist, the function that is the inverse of needs to pass the horizontal line test, which means that if we have a graph of y equals x squared, like this, not quite accurate, but to pass the horizontal line test, it needs to be a one-to-one function, which means that for every y value, there can be only one x value. So if we draw a horizontal line anywhere on the graph, this means that there will not be more than 2 points it will cross. And here it fails the test because basically anywhere you draw the line, it crosses 2 points. Which makes sense because if you flip the graph over on the y equals x-axis to make it the inverse, it won't pass the vertical line test, which means that it's not an actual function. Now, let's do an example. If we have this function f of x equals x to the 5 plus 2x minus 1, and we want to find the derivative of the inverse of this function, we can do it in two ways. So let's first try the first method, where we just rewrite it as y equals this, and then replace the y and x values with each other. So we get x equals y to the power of 5 plus 2y minus 1. And you could try to simplify it so that you isolate y, but pretty sure it's like impossible in this case, and it will be impossible for a lot of other cases as well, or near impossible. And what we can do here is just use implicit differentiation. So we get 1 equals 5y to the 4 dy over dx plus 2 dy over dx. And then we just isolate dy over dx, so dy over dx equals 1 over 5y to the power 4 plus 2. And that's our answer. And whenever we have a point on this x to the power 5 plus 2x minus 1 or an x value, we would plug it into the y value of this, because in inverse functions, the x and y values are swapped, so therefore this will be the x value because it's the inverse function. And now let's do the second method, where we just find the derivative of this and then take the reciprocal of that. So the derivative of this will just be 5x to the power 4 plus 2, and then we just take the reciprocal of that, so 5x to the 4 plus 2. And you can rewrite this as 5y to the 4 because it's the inverse function. So the second method could be easier in this scenario, but in my opinion, if you're not in a crunch for time, I would suggest doing the first method because it makes more sense and it's more safe instead of just doing this method. However, well, for these type of questions, you could just do this method because this is pretty easy anyways, and this is almost guaranteed to work. And if you're confused on whether to write y or x in the variable of the inverse derivative, most times it will be pretty obvious. It will be like stated in the question, and I think most times you will write x. Or a lot of times it won't matter because you will have a value that you need to plug in to the derivative to find the slope. So it won't matter what the variable is, you just plug in the number and you get a number without a variable. But just make sure to always read the question. If you're not sure, most of the times it's going to be x. I just wrote y here because it makes more sense. Now, let's get into some practice problems. If you think you know how to do this one, pause the video and do it. This one says, find f inverse prime of 2 if f of x equals the square root of 2x minus 1. So we can do either method, either rewriting it as y equals the function and then doing the inverse thing, or finding the derivative of this and taking the reciprocal. Let's do both. So first, I'm going to rewrite this as x equals square root of 2y minus 1 and take the derivative using implicit differentiation. And by the way, if you don't know what implicit differentiation is, then I would suggest go watching our video on it because it's pretty essential when using this method. So we get 1 equals 1 over 2 times square root of 2y minus 1 times 2. So we replace the 1 with a 2. And we notice that these 2 can cancel out. So it's just 1 over the square root of 2y minus 1 dy over dx. And this can be rewritten as dy over dx equals 1 over square root of 2y minus 1. And then if we multiply both the numerator and the denominator by square root of 2y minus 1, we just get square root of 2y minus 1 as our final answer. So dy over dx is square root of 2y minus 1. And again, we can't just leave this as our final answer. We have f prime of 2. So if 2 is our x value in this function, then 2 will be our y value in the inverse function. So therefore, we plug in 2 to square root of 2y minus 1. We get 4 minus 1, and we get square root of 3 as our answer. Now, let's do the other method. So let's just find the derivative of this, square root of 2x minus 1, and we get 1 over 2 times square root of 2x minus 1. And again, it's the same thing multiplied by 2, and then the 2's cancel out, so it's just 1 over this. And at this point, we can either take the reciprocal of this and then plug in x, or we can plug in x and then take the reciprocal of that. What I can do right now is just plug in x because I just think that makes more sense. So if we plug in x, this is going to be 1 over the square root of 3, so 1 over square root of 3, and then we have to take the reciprocal of this, so square root of 3. And we got the same answer, so both methods work. So just make sure that whenever you're doing this method, where you take the derivative of this, you make sure to take the reciprocal at the end. You can't just leave it as 1 over square root of 3 in this case. So everything that I explained in this video and all the problems that I went through should teach you everything that you need to know about the basics of how to find derivatives of inverse functions. If you learned something from this video, or if you enjoyed it, please consider liking and subscribing.